Hello grade 12s and welcome to this video on the alkanes. Some of the uses of alkanes is that they can be used to form a waxy coating on fruits or to form a protective layer on human skin, such as the alkanes that we find in Vaseline. The alkanes can be found in fuels like petrol, and they can also be found in devices like cigarettes and gas stoves, where the fuel that they contain and that we burn in order to supply heat are alkanes like butane and methylpropane. In this video, we will specifically focus on how to draw the structural formulae of alkanes, and also we will see how the general formula CnH2n plus 2 can be used to describe a variety of alkanes. We're now going to look at a few examples taken from A. Oliphier's Book 2 textbook on organic chemistry. And here they say, draw the structural formulae of each of the following alkanes. We're going to start off with the one on the left, 2,3-dimethylpentane. Whenever we draw structural formulae, we normally start off by drawing the longest chain. Pent here means 5. Once we have drawn out the longest chain, which here contains 5 carbons, we can draw in the substituents. Here we only have methyl groups, but there are 2 of them. One that falls on carbon number 2 and the other falls on carbon number 3. If we start to number from the left-hand side, then this is carbon number 2 and this is carbon number 3. You can draw these methyl groups at the top or at the bottom of the carbons. Remember, we are drawing 2-dimensional representations of 3-dimensional molecules. So we're going to now draw in those methyl groups. Remember that methyl contains 1 carbon and 3 hydrogen atoms. Now that we are done drawing in the substituents, we need to make sure that each carbon has made 4 bonds. Carbon is special because it has this ability to make 4 bonds, and that is why it has its own branch of chemistry called organic chemistry. If we look at the first carbon in the chain, it has only made 1 bond so far, and therefore we draw on it 3 additional hydrogens. The second one has made 3 bonds, so we draw another hydrogen. The third one also needs another hydrogen in order to form 4 bonds. The fourth carbon requires 2 hydrogens so that it may form 4 bonds, and the last carbon requires 3 hydrogens so that it will form 4 bonds. This is the structural formula of 2,3-dimethylpentane. Now, although the question does not require it, I have written out the molecular formula of 2,3-dimethylpentane, and I would like to use this to explain to you how the general formula works. The general formula of the alkanes is CnH2n plus 2. So this sort of works like number patterns, those TNs or general rules that we use for number patterns. We're saying for this specific compound that it contains 7 carbons, so N is equal to 7. If N is 7, then we can determine the number of hydrogens by saying 2 times N plus 2. In this case, N is 7, so we have 2 times 7, which is 14 plus 2, bringing us to 16 hydrogen atoms. And that is why the molecular formula of 2,3-dimethylpentane is C7, representing the 7 carbons, and H16, where 16 is 2 times 7 plus 2. We can now move on to the next problem, where we need to draw the structural formula of 3,3-diethyl-4-methylheptane. As normal, we always start off by drawing the longest chain. Here we have hept, and hept represents 7. Now that we are done drawing this long chain, we can look at the substituents. I'm going to start off with the methyl. Methyl falls onto carbon number 4. If we start numbering from the left-hand side, then this is carbon number 4, and methyl only contains 1 carbon and 3 hydrogens, so we can draw it in like this. Then we also have ethyl groups. There are 2 of them. We know this because of the word di, and they both fall onto carbon number 3. So we can draw them over here. There are going to be two of these groups, and remember, ethyl contains two carbon atoms. So now we have our substituents drawn, and as in the previous case, we of course need to ensure that each carbon has made 4 bonds. The first carbon requires 3 hydrogens to ensure that it makes 4 bonds. On the second carbon, we can draw 2 hydrogens. We skip the third, go on to the fourth that requires 1 carbon. The next one requires 2. The one after that requires 2, and then the last carbon requires 3 hydrogen atoms, so that in this case each of our carbon atoms only contain single bonds between them because they are alkanes, and each carbon atom has made 4 bonds. We can now look at a few problems that require us to draw condensed structural formulae using the names that have been given to us. We are not often required in tests and exams to draw condensed structural formulae, but if you're able to draw them, then it means that you're able to understand them. And therefore, if ever you are given a condensed structural formula, you will be able to name the compound. It is always easiest to start off by drawing the actual structural formula of the compound before trying to condense it. So I'm going to start off by doing that for 2,4-dimethylhexane. Now that we have drawn the structural formula showing the longest chain, hex, which is for 6 carbons on the longest chain, and we've drawn in the substituents, the 2 methyl groups on carbon 2 and 4. In this case, I have started to number the carbons from the left. We can now go ahead and condense this structural formula. So we start off on this side. Here we have a CH3. So we literally go and write down CH3. We move on to the second carbon. It has a CH, and we're going to write that down, CH. But onto that carbon is a branch, CH3. So we're going to use brackets to draw in this branch like this, CH3. The brackets don't necessarily refer to branches, but we can draw in the branches using brackets. Alternatively, you can attach it using a line indicating a bond onto that carbon, the CH that we have drawn. Now we move on and we see CH2. So we write down CH2. We then have CH and we draw in CH. But attached to that carbon is a substituent, the methyl group. And we're going to indicate that by making use of brackets. And in those brackets, we write down CH3. Now there is a CH2. So we write down CH2, and the last carbon has 3 hydrogens attached to it, so we now write down CH3. This over here is the condensed structural formula of this alkane. Now there are many different ways in which we can represent condensed structural formulae. Sometimes we choose to draw in at least the bond between the different carbons. Sometimes we condense them to this point. I'm going to show you with the next example a different method that we can use. Here we're dealing with 3,3-diethyl 6-methyl-octane, and we're going to start off by drawing the actual structural formula of this compound. The structural formula of 3,3-diethyl 6-methyl-octane looks as I've drawn. It contains 8 carbons in its longest chain, a methyl group on carbon number 6. Here I have started to number from the left, and it contains 2 ethyl groups, both on carbon number 3. Now we can go and draw the condensed structural formula. And I'm going to use a different method in this case. We first still have CH3. So we write out CH3. Then next to that we have a CH2, and we're going to write CH2. The next carbon has 2 substituents, 2 branches attached to it. So we're going to write down C, and then we are going to, in a sense, draw in these branches. We draw in a line over here, and then we say CH2, CH3. where the CH2 is this part and the CH2 is this part of the branch. Below it, I'm going to draw in the branch that is below it. Unfortunately, I drew this wrong, so I'm going to correct that first. It was supposed to be an ethyl group, so I've corrected that. So below it, we're going to have CH2, CH3. Now that we are done with this branch as well, with its CH2, CH3, we can move along. The next carbon has 2 hydrogen atoms attached to it, so we write down CH2. Then we have another CH2, so we're going to write down CH2. The next carbon only has 1 hydrogen atom attached to it, so we write down CH. But then it has a branch, specifically it has a methyl group attached to it, and we're going to draw this using a straight line and CH3. Then there is a carbon that has 2 hydrogen atoms, so we write down CH2. And the last carbon has 3 hydrogen atoms attached to it, so we write down CH3. This is the condensed structural formula of the compound whose name is 3,3-diethyl 6-methyl-octane. We have reached the end of this video on alkanes. In the next video, we're going to take a look at alkenes.